All right, so let's get started. Hello, everyone, and thanks so much for joining us. This event is Real Data Science Examples at OLX's online marketplace, and it is part of the Developer Growth Summit 2022. If this is your very first session joining in this summit, I want to give you some quick instructions before we introduce the speaker and the topic. So we're going to be using Zoom webinar today, and it's completely normal. You can't see the other attendees. You can see people are present. You can see the participants at the bottom of the screen. And feel free to interact in the chat, as some of you have already been doing. Make sure you send it to everyone because the default is set to hosts and panelists. You'll also notice at the bottom of the screen, there's a Q&A feature in the toolbar. So this is where you can ask the host, me, or our guest speaker questions throughout. And towards the end, I will start to ask the questions and really drill down on the things that you want to know most. All right, so there's one other thing I'd like to let you know. Please follow our code of conduct. This is listed in the chat for you, because we want everyone to have a good experience. So just check the link in the chat if you have questions about that. So now I would like to introduce our speaker, Alexey Grigorev. So he's a speaker at this event, and he'll be talking about real data science examples at OLX's online marketplace. So Alexey is the Principal Data Scientist at OLX. He also hosts the DataTalks.Club, which is a community for data enthusiasts. Alexey wrote a few books about machine learning as well. One of them is called Machine Learning Bookcamp. That's B-O-O-K camp. It's a book for software engineers who want to get into machine learning. So Alexey lives in Berlin. He's joining us from Germany today with his wife and son. So without further ado, Alexey, please take it away.
Yeah, thanks for having me. That's an honor to be here. So let us start. So I think the title here is a little bit different from what you said. The content will be the same. So let's look at the content. So first I will talk about OLX, what OLX is. Then we'll talk about data science at OLX, a few use cases. And then I did a bit of added a bit of a bonus section at the end, so I hope we will have time to cover that as well. So I'll talk how data scientists work with the rest of the organization and what are the expectations from data scientists at OLX. So let's start. So OLX is an online marketplace, and I want to say a few words about that. So what is actually an online marketplace? On this picture you see a marketplace. So this is a marketplace from my hometown. So you see people who want to buy some stuff, right? So now there are people who are selling something, and then people who are selecting something, yeah, right? So this is a marketplace. So on marketplaces we have sellers. So sellers are people who are selling stuff, and then we have buyers. So buyers are people with money, and they want to exchange this money to these items, right? So they give the money to the seller, they get the item, and everyone is happy. And when this happens, usually there are places for this kind of exchanges. These places are called marketplaces, and I am pretty sure in every city, every town, every settlement on Earth, there is a place like that where people gather to exchange money for items. So this is a typical marketplace. In online world, there are also places like that. There people can exchange money on things, and these places are called online marketplaces. So this happens through websites, and OLX is one of such examples. Right? So in this picture, we have OLX. I think this is Portugal. So my Portuguese is not really good, so I cannot say if it's Portuguese or Romanian, because we also have presence in Romania, in a bunch of European countries, and then all over the world. Yeah, actually, so there are, OLX is a large group. There are many different brands in OLX. So maybe you know some of these brands, but in many places we are known as OLX. So for example, we are known as OLX in India, in Ukraine, in Poland, in South Africa, and in many other countries. So I work at OLX Europe. So OLX Europe, well, as the name suggests, we focus on Europe. So we are present in multiple places, like you see on this picture. So bigger logos, these are where we have tech hubs, where people actually work on developing things, and smaller logos, these are places where we have offices, where we have presence. So now you know what OLX is and what is a marketplace, and I want to talk about data science at OLX. So again, OLX is an online marketplace. And here there are multiple things where data science can help, or in general different areas where we can help people. So the first area is buyers. So how can we make the experience of buyers best? Like how can they get what they need as fast as possible, right? So that's one area where we can help. Another area is we can help sellers, right? So how can we make sure that sellers sell as fast as possible? Then interaction between them. So they have to, so sometimes there are people who do not always have best intentions. So there are people who are fraudsters. So how can we as marketplace catch them, right? So how can we make this interaction between buyers and sellers safe? And then last thing what we can improve is to actually, for us as online marketplace, how can we earn money by helping buyers and sellers? So there are four, let's say, main areas. And in all these four main areas, we have data science projects. So let's start with buyers. So for buyers, when it comes to buyers, when they come to the platform, they're usually looking for something specific. So for example, I have a phone here. So let's say I want to buy a phone. So let's say I don't have a phone and I want to go to OLX to buy a phone. And usually what happens is I go to search and then I type the name of the phone I want to buy, for example, and then I want to see results that are relevant to me, right? And for example, if I make a typo, I also want to website still show me something, right? So some spell checking, correction, or for example, if I look for, I don't know, Xbox, then I realize that we can understand that this is a query for a particular category. So we can see, okay, this query just needs to redirect to a category. So we can do a bunch of things with search. Search is, of course, not the only thing for an online marketplace. So people want to look for things, but also sometimes people need to get some inspiration. So they, and we call this recommender systems, right? So based on your previous interactions with the website, previous items you bought, previous people you talked to, previous ads you looked at, we want to recommend you things that are similar, things that are close to what you're looking for, things that you might like. And this is the area of recommender systems. And for recommender systems, I don't know, the names that you have, that you see here, maybe they don't tell you much, but these are the names of the systems or recommender systems that we run. So I'll talk a bit more about recommender systems later, but this is a very big and important area for an online marketplace to make buyers happy. Then another area, as I already said, is making sellers happy. And for that, usually we want to make sure that they have no problems with creating listings. So it's very easy to create a listing. And then sellers might have problems with picking the right price. Like, what is the right price for this item I'm going to sell? So then helping them, especially if it's like a car or something, helping them with picking up the right price is quite important. Right? And then other things I have here is, let's say you want to sell something, but you do not necessarily realize the importance of having a good picture, a good description. And in these cases, when we see that the listing can be improved, we want to suggest the seller saying, hey, like this picture looks a bit dark, maybe you can retake this picture and then it will improve your chances of selling the item. Or another use case I have here called deal estimation is sometimes sellers, they have sold something, so they already sold the item, but the item is still live on the platform. So how can we detect such cases and ask the seller to remove this? So, and of course there are more things, but these are the first that come to my mind when I was preparing the presentation. And I think the most important one here is price, especially when it comes to cars. This is where cars and real estate, this is where sellers need help. Another area is the interaction between buyer and seller, and I refer to this as making this transaction safe. And usually here we want to detect all the nasty stuff. So sometimes Sometimes, let's say, sellers, as I said, they do not always have the best intentions. Sometimes it happens that sellers come to the platform in order to cheat somebody, to steal money, for example. They might sell something they do not have, and they might ask for advance payments, some deposit, and then they might disappear with the money. Or things like this, right? So sometimes seller post some pornographic images, some explicit content that we want to remove, or some items that shouldn't be sold on the platform, like weapons or drugs or medicine, or in some cases, for example, things that are related to smoking. Like in many cases, this is prohibited and it should not go live to the platform, right? So in these cases, we want to detect these things and remove them from the platform before anyone sees that. This is quite an important area, like how can we make these transactions between seller and buyers safe? And the last thing is how can we as marketplace make money? And here, like the most obvious one is through ads. So we have a lot of ads on the website, ads from Google, for example. And how can we make sure that these ads are relevant to the user? They are not so annoying. There are not so many of them. There is just the right amount of them. Ads are relevant, and yeah, things like this. So we do it through data science. And another one is user segmentation, like how can we learn more about the users that we have in order to monetize them more effectively. So I will not go into details into this particular topic, but I want to cover two topics. So one topic I want to cover in more details is moderation system, and another one is our recommender system. So let's start with the moderation system. So imagine a seller wants to create a piece of content, a piece of, let's say not content, in our case, they want to create a listing, right? So they come to OLX and let's say they want to sell a dog, or actually selling dogs, I'm not sure it's allowed, but let's say this is a toy dog, right? So they want to sell this, but they want to sell it so badly that they create multiple copies of the same listing. So the item is the same, it's just different pictures of the same item. And this creates a problem, right? So it creates spam on the platform, and people who are actually looking for something, who are looking for dog toys or toys of dogs, they will have to go through all these listings that are basically the same, and this is very annoying. Right, so that is one of the problems. Another problem is some explicit content or some pornographic content that people that is not allowed to post, and usually people post it in order to get attention, and usually it's fraudsters who want to, I don't know, publish some link that they should not. So this thing can also happen. Or, as I said, some people try to sell guns. In this particular case, actually, so you see that there is this red thing on the gun, so this means that this is a toy. But again, it's not always clear. When you see something like this, yeah, this shouldn't actually appear on the platform. So all these problems, like the list of problems, can go on. So there are illegal items, not safe for work content, duplicates, spam, fraud, and so on. So how can we actually deal with these kind of problems? And we can deal them by building a content moderation system. So a content moderation system is a system that looks at the content that people publish, that sellers publish, and removes some of the content that shouldn't be on the platform. So how can we build such a platform? So first, it starts with the seller posting, creating a post, right? And this post then goes to an automatic moderation system. This is just a fancy word of saying that there is a bunch of machine learning models. Each of these models look at the listing and then they decide if it should go live to the platform or not. So they basically decide whether they want to accept it, and if they accept, then it goes live to the platform. Or they say, okay, this is suspicious, this looks like a gun, or this looks like a pornographic image, then it's rejected and it does not go live. It's not always black and white. Sometimes the model can be unsure, and in this case, these listings go to a moderation queue, and which means that these listings are picked up by people, moderators. So they have a special tool called moderation panel, where they look at these things and they make the final decision if this should ultimately be accepted or rejected. So this is, of course, it's a very simplified picture, but you see that automatic moderation system, which contains machine learning, happens before moderators. So the goal here is not to replace moderators, but help them be more effective. Only consider cases when it's not clear which decision should be taken, right? So it's not completely replace humans, but more like augment humans and make their work more, I don't know, less boring. So the goal here of automatic moderation system is to pre-moderate as much listings as possible, only leaving tricky cases to human moderators. And then this automatic moderation system contains of multiple components, all these problems that I described. So we have a special component, a special model, a special subsystem that deals with this particular kind of problem. So for example, we have a system for duplicate detection, we have a system for forbidden items, and a bunch of other things. So here on this picture, this is like a busy slide with a lot of things. So this is how our duplicate detection system works. So first, when a new listing, so this is a bit technical. I don't know how technical you are. If you're more technical, this could be quite interesting for you. So first, when a listing is uploaded, it goes, like we save it to S3, and then from S3, there is a separate process kicked in. So we compute things called hashes and other characteristics of images. Then we store all these things in Elasticsearch cluster to understand that this image and the other image is similar. And then we use that and other information from the listing, like, I don't know, IP addresses and things like this. I will not go into details, of course, not to tell you too much, but we'll look at all the information we have in order to understand that something is a duplicate. So first we index all these images and other information we have. And then we have this piece of the system called duplicate detection system. Inside it has a machine learning model that looks at two duplicate candidates, and then it makes a decision whether this pair is actually a duplicate or not. And if this is actually a duplicate, then we send it to, we either automatically reject it or we send it to moderators. And the interesting thing happens after moderators review, because we collect feedback of what is a duplicate, what is not duplicate, and then we feed it back to the system in order to have a better model. So this is roughly how it works. Of course, there are a lot of details here that I do not cover, but this is roughly our overview of this duplicate detection system. And we have similar systems here as a part of automatic moderation system. If you want to find out more about these systems and how we go about detecting duplicates and how do we go about moderating content, we have a tech blog. So the tech blog is tech.olx.com. and you can check it out. So there are a few articles about that. So I briefly described the moderation system. Now let me talk a bit about the recommender system. So let's start. So on this picture, you see OLX Poland, and this is the main picture. So when you go to the main website, you see these things. So this is what we call home feed. And for this home feed, we want to show items that are relevant to you. That's something based on the items you previously interacted with. We want to show something relevant. So for example, if you're into, it seems for me like it shows a lot of, this wooden stuff. I don't even know how this is called in English. But if previously I was looking for this sort of things, then next time I come to the website, it will show me similar things. So think of YouTube. So you probably use YouTube. So when you go to YouTube, it shows you things that you might like, right? So in a similar way, we also want to show things that you're more likely to buy, right? Or be interested in checking. So how can we do this? So for that, we have a system called recommender system. And the way it works, it's a little bit technical right now, but we need to get all the interactions we have between users and items and put them into this huge matrix A, and then use a thing called collaborative filtering. And what it does, it extracts the vectors, like we can represent each item and each user as a vector. And like maybe not of you like math, but you're developers. And when you hear vector, you can think of an array of certain length. So let's say an array with 16 numbers, right? So this is just vector is a fancy word of saying that. So now we have each user and each item represented as an array of 16 floats, 16 doubles, so 16 numbers, right? And then what we can do with this is we can actually put them into a vector space. And the vector space is, let's say there is an item, socks, and then there is other item, a teddy bear, and then there is a vector for a person, right? And in this case, this is 2-dimensional, but usually in practice it's 16-dimensional or 32-dimensional vectors. Again, arrays with 32 numbers. And then we can see which things are close in space, which are not. And for example, for this user, we see that this user is more into socks, and then we can just find vectors that are close to this user. If none of this makes sense, but you want to learn more about this, there is a nice paper called Matrix Factorization Techniques for Recommender Systems. If it's the first exposure to machine learning for you, might be difficult, but if you already know a thing or two, I definitely recommend checking this paper. It's good, and it describes, it's a relatively old, or I should say classic paper, but it describes quite well the process of going from items and users to vectors. And then we use the things from linear algebra, from mathematics, to actually come up with these recommendations. Oh, these ones, right? So and then we save these vectors to some database, and then we can look similar ones. So this is how it works. And there is another recommender system we have. So previously I showed you the home feed, but also let's say if I click on this thing here, like this is some, I don't know, something for acoustic guitars, right? I think. So if I click on this, this is what it shows me, right? And this is the main item. And if I scroll a bit down, then I see other things, like you can check also these things, or people who look at these things also check these ones, or like maybe on Amazon you see people who buy this item also buy that item. So this one uses a slightly different approach from the previous one. So this previous one is personalized recommendations for you, but these recommendations are recommendations that are similar to this item. So they are a bit different. And the way it works is we have these vectors from the previous. So previously we were trying to find, so for this user, what are the items that are close to this user. But what if we take these socks, this item, and then try to find all the other items, not teddy bears, but I don't know, other socks that are close to this one, and then we can use this for actually making this recommendation. So we can use these vectors that we produced on the previous step, compute some similarity between them, and show this to the user. Or we can use a neural network, and I have a very scary slide. This is just a neural network. I don't want to go into details of what it is exactly doing, but high-level overview, it gets an item, and then it produces a vector like this, an array with 16 numbers. And then this works better than the collaborative filtering approach. And if you want to find out more about this, there are two links here. So for example, this one, so this video, I'll share the slides with you later, but you can just check, look it up, Deep Learning Recommender Systems by Christian Martinez and Ilya Ivanov. They are my colleagues, and they talk in more details about this. And I think by now, we actually also have an article about this in our tech blog. So yeah, so this is our recommender system. And actually, that is the main part of the talk. So by now I'm supposed to finish, but I know I have a bit more time. So that's why I want to spend this time talking about other things. So this is the bonus I promised at the beginning. So I also want to talk about how we data scientists work with other people in the company. So as you see, as you can imagine, that projects like that are very complex. So one person, one data scientist cannot really possibly work alone on this project. It requires an effort of many people, of a team or multiple teams. Actually, at OLX, 3 or 4 teams work on this, have worked for the last 6-7 years. There are always new things to work on. So data science does not happen in isolation. We as data scientists need to work with other people in the company. And I want to tell you how this collaboration happens. So how we can do data science with the rest of the people in the teams. And let's first think who we have actually in the team, in addition to data scientists. Actually, I have data scientists here as the last ones, because they're by far not the most important people, of course, in the team, but I started with them because we're talking about data science here. But I think, in my opinion, the most important person on the team is a product manager. So they are the people who make sure that the team is actually working on solving the right problem. So, because sometimes it happens that engineers, if you just let them do their things, engineers, data scientists, I mean everyone, they will try to solve problems that do not exist, simply because these are the fun problems to solve, right? And the job of a product manager to make sure that this energy is well spent on problems that actually matter. And we have engineering manager, this person who manages engineers. We have different engineers, backend engineers, data engineers, machine learning engineers, list goes on. Then we have analysts on the team, and we have data scientists. So these are not, each team has all these roles. So some teams have only some of them, but typically a data science team at OLX, I think I have a picture here. A typical team at OLX, it contains a bunch of people from different backgrounds. So each team should have a product manager. And then we have, maybe some teams have analysts, some teams do not. Some teams have data scientists, some teams do not. Most teams have backend engineers and front-end engineers. Some teams do not have front-end engineers. But this is typically a structure that we have. And this is, let's say, a department. In a department, we have multiple teams. And then for each sort of, I don't know, vertical, for product managers, they have their own managers. For analysts, they have their own managers, and so on. So this is roughly the structure. And everyone on the team, even though we have all different managers, we work together, and we're guided here by product managers. Yeah, I think I described that. Like, each team is a feature team of different people with who are experts in different areas, and we work on the same goals. And how do we set these goals? For goal setting, we use a thing called OKR. OKR is objectives and key results. So this is something we set quarterly. And yeah, so this is what are the things that we want to work on in the next quarter. And here we do not mention solutions. We say what is the state we want to be in 3 months. So for example, if we talk about a moderation system, we want to say that there is some fraud on the system and we want to catch as many fraudsters as possible. But how do we measure that? Like, how do we say, okay, now we actually caught many fraudsters? We can say that we want to reduce the level of fraud happening in the system by X, right? Or we want to say that by this, we want to, this model, we want this to be more precise, right? So we want, I don't know, duplicate detection model, catch more duplicates, because we know that fraudsters often create duplicate listings in order to, I don't know, attract more victims. Or another KR could be that we want to take this model and deploy it in our key markets. And we do this every quarter. And these goals are visible typically. So every team knows what the other team is working on. And if there are some areas where we can collaborate, work together, we try to come up with OKRs that we call them shared OKRs. And yeah, so this is how we work together. We work in cross-functional teams, and we use OKRs as a way of aligning and setting goals. And maybe the last thing before we finish, I think I finished a bit earlier than I planned. But yeah, the last thing I wanted to talk about is the expectations from data scientists. Because data science is such an overloaded term, and every company sees data scientists differently, data science differently. I don't think there is a good definition of data scientist now, even though this is not a very young role, let's say, because data scientists have been around for 8 years or something like this. By now it should be already established, but it's not. And so, for example, data scientists at Google and data scientists at OLX are doing pretty much different things. But let me tell you what actually we expect from data scientists. And if we think about the data science projects, so data science projects, they start with understanding the problem we want to solve, and this is usually product managers drive this part. Then we need to collect some data, process this data, create a model, evaluate this model, and then put this model to production. This is a team's effort. This is not just something that the data scientist is doing. This is like a team. Collectively, everyone on the team works on all the stages of this process, right? And then let's think of data scientists. So data scientists' core responsibilities are modeling, so creating a model, and then evaluating this model. So we create a model. How can we make sure that this model is actually, catching fraud, right? Of course, data scientists take part in other steps. So for example, at the beginning, they jointly work with product managers to define the problem that we want to solve as a team, but this is their main focus. And I think this is more or less similar across different companies. So many companies agree that data scientists should work on modeling and evaluation of models. But we also, for us, data scientists are also, they know a bit of engineering, because so it's not enough to create a model. We also need to know how to deploy this model. We use things like so scikit-learn is something we use for training, but then how do we go about taking the model we produced and putting this as a microservice? How do we, like let's say we use Flask, how do we put this Flask up and deploy this to the cloud, AWS in our case? So data scientists should be comfortable solving these problems for us. And of course, I think I had more slides here, but of course, I have this dotted thing here. So some data scientists, they want to go more in the production side of things and work closely with machine learning engineers. They like when it comes to deploying models. Some prefer to work closely with data engineers. So they take care of data processing. Sometimes in some teams, we do not have machine learning engineers, we do not have data engineers, so data scientists have to do all that. Well, there are software engineers, but they often work on integrating services that data scientists created into the backend system of OLX. I think that's roughly it. So if you're interested in working with us, we have open positions. So you can check the open positions. We're hiring pretty much worldwide. So check it out. It's joinolx.com. So if you're from Europe, Germany, Portugal, or Poland, check it out and you can reach out to me if you have questions. I can answer questions about these 3 locations. Unfortunately, I cannot answer about others. And then our tech blog. And if you want to reach out to me, you can check my website. Then there is a cool community of data enthusiasts called DataTalks.Club, and if you want to find me, the best way is to find me there. And I think I am done. So I see that there are a bunch of questions, so now I'm ready to take these questions.
All right, so I'm just jumping back on as well. Can everyone hear me? Alexey, can you hear
Yes.
my voice? All right. Thanks so much for that. I think you provide a lot of really real world examples related to the marketplace. So I think everyone learned quite a lot. So we do have a few questions, so I will go through those. And if you have additional questions and you're in the audience, feel free to drop those into the Q&A section and we'll get to those. Okay, so the first question is from an anonymous attendee who's asking about, was SVD used in this collaborative filtering? If you remember that section you talked about.
Yeah, so we do not, well, it's kind of, I don't know if it was or not, because SVD is more like an approach that could be used everywhere. But when it comes to actually implementing this, we use a library called implicit. So this is a cool library, and we use that. Yeah, so I think it uses something like alternating least squares inside. There are different solvers, but yeah, this is what we use.
Okay, thank you. A question from Daphne. For developers who want to get into data science, what are some of the most important skills to master?
Okay, so as a developer, you're already ahead of your competitions because you may be, and by competition, I think what I mean here is like, let's say there is a group of people who want to enter the data science field right now. So they are all coming from different backgrounds. And like some are coming from academia. So they, let's say they were doing physics, now they want to go to data science. So they build on their mathematical background because they can easily read a paper, understand it. But you as a developer, you already have 90% of skills that you need to actually be successful at your role. So you only need to somehow figure out this 10%. Right? As a developer, you already know how to deploy applications, how to write good code, and these are all important skills. These are very important skills because, as you saw in all this in my presentation, I talked about building these systems, right? And as a developer, you already know how to build the systems. So you just need to focus on this remaining 90% and this remaining 10% to convince actually a potential employer that they should hire you. And these are typically simple models, like what is a linear regression, what is a logistic regression, what kind of problems you can solve with these models, what is a decision tree. And one important thing you need to really know how to use well is called cross-validation. This is an approach or a framework for evaluating your models. So you need to master that. If there's anything you need to master, this is cross-validation. And yeah, so focus on practical things. So instead of getting a textbook from a library which has like 900 pages and reading end to end, I think it's like if you're into this kind of stuff, do this, but I'm not sure if this is the best way of spending time. So instead, I would focus on actually getting practice, getting a data set, and trying to apply a model to this data set. You probably don't know how to go about this, but Google is your friend, or whatever search engine you like to use, Bing or whatever. So just use that. And of course, here I feel like adding a shameless plug. So there is a book that I wrote called Machine Learning Bookcamp. And this book actually is targeted. I'm not sure if targeted is a good word, but this book is written by 4 software engineers who want to transition to data science. Because my background, actually, I was a Java developer, so I was a software engineer, and then I became a data scientist. And that's why I wrote this book. I want to help other software engineers also make a similar transition. So at least check the table of content, and that will give you some idea of what you should master. Another shameless plug is we have a course based on the book, which is actually free. It's called Machine Learning Zoom Camp. And check it out. It's completely free. I think if you just Google, you will find it. And it also shows it will show you the most important things you need to master.
Thank you. That was a great answer. So we have sort of a related question from Andrea Nino, and they're asking, what is the best advice you can give for a future junior developer who's studying on their own and wants to focus on machine learning on the side? So you touched on that a little bit, but do you think it's the future, or is it already very saturated? This person is learning Python, and deepfakes are something that caught their attention.
So learning Python is good. Please do this. Keep learning Python. Even like you asked me if it's saturated. I don't think it is. So it is very difficult for a junior to enter the field, but the field is not saturated. There is always demand for people who can do this stuff. It's just for juniors, it's always difficult to kind of show or prove that they can do this. So it takes a bit more time to actually land the first job. But yeah, once you have this, once you have half a year of experience, then all of a sudden saturation disappears, right? And everyone wants to hire you. So you just need to persist before you get your first job, before you get your first experience, and then it will be fine. And yeah, so learn Python, that's a good thing. So all these best software engineering practices like writing clean code, writing tests, using version control, all this is important for machine learning as well. And I think what is important here is to have a portfolio. So let's say somebody wants to hire a machine learning engineer, right? And then they look at two CVs. So one CV has a portfolio and another one does not. So the person who has a portfolio, they have a way to prove that they actually know how to do this thing. So yeah, better have something like this. It's not a must, but I think it will help you to get more attention. And it's also helpful to have a portfolio to be able to have something to talk to interviewers, because I often interview people, and let's say we start the interview, I ask the candidate about to tell me about themselves, and then I ask, hey, can you tell me a few projects you took part in? And if the answer is, oh, you know, I didn't really take part in projects, then it's a bit awkward because I don't know what to talk about, and then I start grilling you with theoretical questions, and this is not what you want to have on the interview. So better to have projects prepared, and then you can talk about these projects to the interviewers, right? So you don't want to talk too much about theory. So yeah, focus on building projects.
That's a really great tip, to build projects. We have one last question, which is about joining a hackathon. So if someone's interested in joining a hackathon, do you have any particular type of hackathon you'd recommend?
Are there different types of hackathons?
I'm not sure.
The one you like, I guess. If you don't like, don't take part in it.
Yeah.
I don't know.
Honestly, just yeah, I think that makes sense.
Yeah, like if there is, if you like the people, if you like organizers, if you like the problems that they want to solve, or any of these things above, then it's probably a good hackathon. Because output of a hackathon is a project, and you want to have projects, right? And yeah, and this is all valuable experience, because usually on hackathons you're not hacking this yourself, not hacking this alone, you're working with others, and this is also a very valuable skill. So maybe any hackathon would do, unless you really resent the topics and people who organize it. So then maybe don't do it.
Yeah, and doing it with people you like is also a good tip, because you're going to be spending a lot of time with them.
I mean, I just didn't know what to say. That's why I bring this up.
I think it's a good tip.
Any hackathon is good. Yeah.
For sure. Okay, thank you. So I think, we have a few more questions popping up. Let's see. I'm a cybersecurity domain, but in operations. What would you suggest? I don't know if that's clear enough.
I have no idea what is cybersecurity in operations.
Okay.
And what would I suggest for what? I guess maybe since this is about data science, like what they can do to get into data science. Well, a few important things. So you need to be comfortable with programming. You don't have to be a great software engineer, but you have to be an okay software engineer for data science. Right? So focus on that. And even if you realize after some time that you don't like data science, then you can always do software engineering. So the next immediate step is to, I don't know, pick Python if you don't know it, and do a project in Python. I don't know, learn Django or something.
Another question related to the one you were discussing about for projects. Is there a particular number of projects that you would need before you're interview ready?
Well, at least one or half. It's better to have one finished project. Because as I said, if you don't have a project, but you somehow manage to get to the interview, then it's awkward, because I personally do not know what to talk about. And then I can ask, okay, tell me what you learned in your machine learning class. And then they would tell me, oh, I learned this thing called logistic regression. And then, it will happen that, like, because they learned logistic regression, I would think, okay, let me check how well they learned it. And then I would start, asking whatever in more details, digging deeper. and then yeah, so theory. And then at the end, maybe we talk about theory, but then we will need to talk about hypothetical projects, and it's always good to have at least one project to talk about. Then you can talk end to end, maybe, like from the very beginning when you collected a data set or found a data set somewhere to the end where you deployed something. This is the best project that you do end to end. If you just found a data set and trained a model on that, this is okay-ish, but it's better if you do things end to end. So 1 is enough, 2 is good, 3 is better. But there is no such thing as interview ready. You're always ready. You can start interviewing right now. And this is another tip. Just start interviewing and you will see what people actually need. If you're able to get an interview or something is missing, you're not getting interviews, then you can try to figure out why you're not getting interviews. Is it because of the project or lack of projects, or because of something else? Yeah. So maybe there is something else that prevents you from getting these interviews. So yeah, just start interviewing.
We have another question related to careers and opportunities. What do you think about remote opportunities? Do you think that there's a lot of those available for data science?
I think so. Yeah, it's like now, after COVID, all of a sudden companies realize that it's actually not that impossible to work remotely. So before that, everyone was, okay, how can we work outside of office? It's not possible. But now all of a sudden we realize that it's actually not that bad and it's possible to work remotely. But then another thing is usually, for example, let's take OLX, right? So we can hire people remotely, but only, let's say, within Germany. So you have to be in Germany to work for OLX Germany, or you have to be in Portugal to work for OLX Portugal. You cannot work from another country because of reasons, right? So there are some reasons why we cannot just hire anywhere, like a person from Australia to work for Germany, because there are complications, right? But in general, it is possible. And I can come to the office, but if I decide not to, I can just work from home as well.
Yeah, I'd also like to mention our sister company actually is made to help developers looking for remote opportunities. We were created for that purpose. So if you're interested, you can check out arc.dev, for different remote opportunities around the world. So yeah, I think we're only going to see the continued growth of remote, as you said. Sometimes it's limited to countries, but I think more and more people are realizing there's tools and ways to work no matter where you live.
And maybe I can add to that. So Berlin is traditionally more like a city of startups. So there are startups that, there are a lot of startups there. But recently, more like, not traditional, but like these tech companies like Twitter, GitHub, they started hiring in Germany as well. They don't have an office here. They just thought, okay, now we cannot hire in London, or we can hire in London, but there are not enough developers. What are the other cities we can hire in? And all of a sudden they notice, okay, there is this city, Berlin, maybe we can hire there as well. And yeah, because they don't need an office, people are already working remotely there, right? And we just see more and more positions from companies like, I don't know, Twitter that weren't present in Germany before, but now because of remote working remotely, they're here. And I think it happens everywhere, not just in Berlin.
Yeah, that's a great point. So not just data science, but all positions, whether it's development.
Yeah. So I meant generally like IT, like software development, design, product management, data science, or all data-related things.
Exactly. We have another question. I like all these keep coming in throughout the talk. Is Kaggle useful in real work?
Kaggle? Kaggle. I usually say Kaggle.
K-A-G-L-E, Kaggle.
Yeah, I usually say Kaggle, but I don't know what's the right way to pronounce it, to be honest. Kaggle. Anyways, yeah, I think it is useful. Just don't spend too much time on it, because Kaggle teaches you useful skills, but some of the skills that Kaggle teaches you are not directly applicable to work. Some of them are very applicable. So for example, you can learn how to do cross-validation, one of the things I mentioned, which is a very important skill to learn to work. And then you can also see what kind of problems you can solve with data science. So on Kaggle, there are many different problems. And then you can understand, okay, if there is a competition on Kaggle, for solving these problems, then in general in the industry it's possible to solve this problem or similar problems with machine learning. So for this thing, Kaggle is also useful. But then if you want to get the first place in a Kaggle competition, you will need to put a lot of effort, a lot of time there, and the skills you will pick in order to become the first to win a Kaggle competition are not always directly applicable to work. It's fun, but yeah. The short answer, yes, it's useful, but not everything.
Okay. A question from Lucao Raphael. Must I be a master of calculus to become a data scientist?
No, that's... Maybe let's start with a simpler question. Do you need math to be a data scientist? Yes, but you do not need math to start your data science career. And for developers, I remember myself when I became interested in data science and machine learning, the most scary thing was formulas. Okay, I look at this formula and my mind just goes blank. I refuse to understand what's going on there because it's math, it's scary, right? And then I had to take some mental effort to realize that this is not scary. And the way I did this is by understanding that every mathematical operation can be expressed in code. And once I myself just sat down, I opened Python, or back then it was Java. So I opened Java and I programmed all these matrix multiplication operations. And then I understood, okay, this is just a bunch of for loops. Now I understand how it works. Now matrix multiplication is no longer scary for me because I know how it works. So maybe for you, you can do that. And there is only a limited subset of mathematics that you need for machine learning. Like you don't need all calculus because calculus is vast. If you want to go into theoretical machine learning, you only need derivatives and a bit of linear algebra when you multiply matrices. So this is something like, forgive me for saying that, but this is just the first year of calculus and linear algebra at university, so it doesn't really go into advanced topics, and you definitely do not need to have a master's degree in mathematics to become a data scientist. So yeah, focus on coding, focus on bringing impact with your coding skills, and you'll be fine. So, and focus on projects, focus on practice.
These are great tips. Another question is, what do you think is manual automation QA? What is the future outlook for those?
I do not remember last time I worked with a QA. So I cannot comment on that. Maybe this is also partly answers that, what the future is. Yeah. Like seriously, I've been working in IT since 2010, and the last QA I interacted with was in 2012, I think. So maybe I didn't happen to work with QA. I know that there are companies who have QA quality engineers, but what I see the trend is developers are responsible for testing their code for code quality. I don't know if this is the best decision, but I see fewer and fewer QA engineers now. And in none of the companies I worked in the last 5 years, there were QA engineers. At least I didn't work with them. So maybe actually OLX is a very large company. There must be QA engineers. I just didn't work with them personally. Yeah. And from what I see, QA engineers usually go into DevOps, into security, into related areas. Some of QA engineers, they became business analysts or product managers. Yeah, but I don't know if it's a good, let's say, prediction, but I don't see a lot of QA engineers around me.
Okay. Another question about the Kaggle. Did you win a competition for the Kaggle competition?
No, I did not. The closest I was to the top was 5th place, which is like a gold medal already, which is considered cool. And in order to do this, I spent 3 months like working almost full time on that. So I would wake up, do some stuff on Kaggle, start the computation, then go to work, then maybe during lunch breaks, look at what how my algorithms are doing, if they improved, maybe submit something and work the rest of the day, and then in the evening continue doing this, and then I would spend time on the weekend. This was fun, but this is not healthy, right? So maybe this is just not for me. So after 3 months of working like that, I realized that I do not want to be in a Kaggle competition. That is just too much time. But that was fun, right? And of course, I should mention that before spending these 3 times and getting there, I was doing Kaggle for half a year at least, maybe not with that much effort. But here, yeah, of course, if you put effort, you will learn a lot, you will get a good place. But the question is if it's worth it. To me, once it was fine, 2 times too much.
Okay, we'll end with one final question. And if you didn't get your question answered, you can reach out to Alexey after this. Do you use any deep learning libraries such as TensorFlow or PyTorch? If so, how to learn these?
Okay, well, short answer, get my book. I show how to use Keras and TensorFlow. Long answer, it's also a short answer. Just find a data set you like, build a project, train a model. Yeah.
Okay.
So this is how you learn. Of course, you can learn all this theory in the world, but it's better to spend your time on projects.
Right. So Alexey, what is the best way for our audience to connect with you? I know you've given a few different ways they can reach you. Which one would be your preferred method?
DataTalks.Club. Join DataTalks.Club and then you'll find me there.
Okay. And do you have any final thoughts or words of encouragement for the audience today before we end?
Don't be scared of math and do projects.
Awesome. Well, thank you, Alexey. This is the official end of this session, so thank you all for joining. So just a quick reminder that we do have a swag giveaway going on. So we encourage all of you to share any learnings, questions, screenshots of the slides from today on social, and be sure to tag us with the hashtag DGS2022. So we'll be picking some people and we'll be sending swag to you all. So also, if you're a speaker yourself and you'd like to do your own event like this, please check out Codementor Events homepage, and all the links are in the chat. So the next event today is Avoiding Burnout as a Developer. I will also be the host of that one. There'll be practical steps and tools by Jen Loper. So this will happen at 8 a.m. PDT, Pacific time. So hope to see you there. I will leave this on for another 5 minutes just to leave this information showing, and we'll wrap up after that. And the link will stay the same. So if you'd like to join us for the next session, please go ahead and use that same link.